Okay, so now we're going to do 13, and 13 has a lot of geometry in it, so it'll be great fun. So what we have here is we have some liquid, and on top of this liquid, or floating in this liquid, we have a cup, and the cup has stuff in the bottom of it. So in the bottom of this, we have glycerin. And over here we have alcohol, and the cup itself is made of aluminum. And we know that this is,
I don't drink.
that's a 30 centimeter diameter. And we have several other numbers. We know that our aluminum is 0.923 coups, and we know our glycerin is 1.35 coups, and we know that the volume of the cup is 4.35 liters. Now I ask you two questions. I ask you how much of the cup is above the alcohol. So we want to know that distance. And I ask you what's the difference in height between the alcohol level and the glycerin level. So we want to know that. This make sense?
Yes, sir.
So it is going to sink until it hits equilibrium. So what's pushing down?
The weight of the aluminum and glycerin.
Yeah, the weight of these two. And again, we can cancel G out, so the mass of alcohol displaced will equal the mass of the two things that are pushing down, which would be the aluminum and the glycerin. So if we add up the aluminum and the glycerin, 0.923 plus 1.35, that's going to give us a total of 2.273 kilograms is being pushed down, so we must have 2.273 kilograms of alcohol displaced. That make sense? And this only works because we're floating. If we were sinking, this wouldn't work. But we know since we're floating, it's going to displace an equal mass of fluid. So then again, since density equals mass over volume, we have the mass. If I'm looking for what volume of alcohol I'm displacing, then these two are going to have to trade. So I'm going to take that and I'm going to divide by the density of alcohol, which is 0.816. And that gives me 2.79 liters, since we're in kilograms. So we have 2.79 liters of alcohol displaced. Now the glycerin down here, again we have a mass. So if we take the mass of the glycerin and we divide it by the density of glycerin, which is 1.26, that's going to give me 1.07 liters of glycerin.
Glycerin.
Now our cup is what shape? It's cylindrical. What is the volume of the cylinder? It's pi r squared times, we'll call it the length. pi r squared times the height or the length. And so the length is what's going to be important here. So I'm going to have to take these two things and take these two things and move them down yonder
Down to yonder.
to find the length. Now, I gave you the bottom of the cup. Everything here is in liters except our diameter. Our diameter was given as centimeters. So I'm going to convert to milliliters because that's really cubic centimeters, and that'll give me stuff in centimeters, and I can do that easier. So first I'm going to take this volume here and I'm going to convert it to milliliters. So that's going to be 4,350 milliliters. And we're going to divide that by pi r squared. But what is my r?
R is 15.
Yeah, the diameter was 30, so the radius is going to be 15. So 4,350 divided by pi divided by 15 gives me 6.15 centimeters left over as my height. So that tells me that this total distance here is 6.15. Then we switch to the glycerin and we say, hey, let's do that same process with the glycerin. So now we're going to have 1070 divided by, again, pi 15 squared. And that gives me 1.51 centimeters. So that's going to be that distance. Does that make sense?
Subtract. No, wait. Don't.
We have to do that one more time because we have the total alcohol displaced is here. So now we're going to take that and we're going to say, hey, that's 2,790 milliliters of alcohol. And again, we're going to divide that by pi 15 squared. Mm-hmm.
Okay. I mean,
And we get 3.95 centimeters, which tells me that this distance is 3.95 So if I take the green number divided or minus the blue number, that'll tell me how much is between the two levels. And if I take the red number divided by the green number, that'll tell me how much is above the top. Five minus